imagine the Mediterranean Sea. In our minds, it is a picture of peace, deep blue water sparkling under the sun-drenched coastlines with ancient towns, and a rich history of civilization that sprouted from these very waters. It is a symbol of vacation, of history, of life. But what if I told you that this entire beauty, this entire ocean, is just a recent guest? What if beneath that deep blue water lies a buried secret, a memory of a lost world? A world where the Mediterranean was not an ocean, but a giant, hot, and deadly salt desert, kilometers deep below sea level. Welcome back to Science for Sleep. If this journey to explore one of the most incredible geological events in Earth's history sparks your curiosity, a gentle tap of the like and subscribe buttons will help our channel continue to explore these great secrets. And I would also love to know, where are you listening from tonight? Please feel free to leave a greeting in the comments, so we know how far this story has traveled. Tonight, we will journey back in time together, to a moment when an ocean disappeared from the world map, and was then reborn in an unimaginable flood. This is a story of collapse and renewal, a reminder of the extraordinary power of our planet. Let us begin together. Our story begins, not with a sudden catastrophe, but with a movement so slow it is imperceptible to any living creature. It is the silent, relentless game of tectonic plates, a process that operates on a timescale of millions of years. Imagine the Earth's crust not as a single, solid shell, but as a mosaic of immense, interlocking pieces, like the plates of a great suit of armor. These tectonic plates are not static. They float upon the hot, viscous mantle beneath them, drifting with the slow, powerful convection currents of the Earth's deep interior. In our story, two of these giants are on a collision course. The Great African Plate, carrying the continent of Africa, moving steadily northward, and the vast Eurasian Plate. The movement is unimaginably slow, only a few centimeters per year, roughly the same speed at which your fingernails grow. But over millions of years, this slow, steady push is powerful enough to raise the Alps, to shape coastlines, and, in our case, to close an ocean. It is like a great stage curtain being drawn, millimeter by millimeter, across a theater. A process so slow you would never notice it in a single lifetime, but one that is destined to eventually close and change the scene entirely. 6 million years ago, the stage was set. The connection between the Atlantic Ocean and the Mediterranean Sea was much wider and deeper than the narrow Strait of Gibraltar we know today. In fact, there were likely two separate gateways, one in northern Morocco and another in southern Spain, allowing the Atlantic's cool, deep waters to flow freely, replenishing the Mediterranean and keeping it alive. But as the African Plate continued its inexorable push northward into the Iberian Peninsula, this connection began to narrow. The seafloor between the two continents was slowly uplifted. The gateways began to shrink. This was not a violent process. It was a silent, geological squeeze, playing out over an immense timescale. There were no witnesses to see the change day by day. There were no sudden earthquakes that sealed the passage in an instant. There was only the slow, inexorable logic of geology. Eventually, after millions of years of this slow pushing, the connection became a shallow, tenuous channel. And then, one day, around 5.96 million years ago, perhaps due to a slight drop in global sea levels or one final geological uplift, the gateways closed completely. The curtain had fallen. The Mediterranean Sea, once a vibrant arm of the Great Atlantic, was now an isolated landlocked lake, a vast body of water cut off from its primary source. And now, alone under the relentless glare of the sun, it began its long, slow process of dying. The great gateways to the Atlantic were now sealed. For the Mediterranean Sea, this was the moment its destiny changed. It was no longer a vibrant, bustling arm of the world's great ocean, constantly refreshed by deep Atlantic currents. It had become a geological prisoner, a vast, isolated lake, sentenced to a slow and solitary fate under the unforgiving sun. At first, the changes would have been imperceptible. The sea was still immense, a body of water so large that its memory of the ocean was long and deep. The great rivers of Europe and Africa, the Nile, the Rhone, the Ebro, continued to pour their fresh water into the basin, just as they had for millennia. But this was a battle against thermodynamics that the rivers could not win. The Mediterranean lies in a region of intense heat and low rainfall. The rate of evaporation from its vast surface has always been incredibly high. In its previous life, this lost water was constantly replenished by the steady inflow from the Atlantic. But now, with that lifeline severed, the balance was broken. Every day, more water was lost to the sky than was being brought in by the rivers. The Great Sea began to shrink. This was not a rapid draining. It was a slow, geological exhalation. Over the course of 1,000 years, a process that would feel eternal to a human, the sea level would drop by hundreds of meters. Imagine standing on a coastline in what is now Italy or Greece. Every generation, the sea would be noticeably farther away. Harbors that once welcomed ships would become dry, dusty valleys. Islands that were once surrounded by deep water would become high plateaus. Their coastlines now strange, chalky rings far below. The Great Sea was retreating, pulling back from the land it had shaped for millions of years, leaving behind vast, salt-encrusted plains where the seabed once was. A new, strange, and barren landscape was being born, a quiet testament to the slow death of an ocean. As the sea level of the vast, isolated Mediterranean dropped, meter by patient meter, the water that remained underwent a profound transformation. Under the constant heat of the sun, evaporation acted as a great filter, lifting pure water vapor into the sky and leaving all the dissolved salts behind. The concentration of salt in the remaining water began to climb, slowly at first, and then with increasing speed. The sea did not disappear all at once. Instead, it likely fragmented, with the deeper basins becoming separated from each other by newly exposed ridges of land. The single, Great Lake became a chain of smaller, but still immense, hypersaline lakes, each one a separate cauldron in the sun. Life in these lakes would have been difficult, if not impossible, for most marine creatures. The water became a harsh, briny pickle, a chemical environment hostile to the complex life that had thrived in the open ocean. Fish, mollusks, and the delicate organisms that formed the base of the food web would have died off in their trillions, their remains sinking to the bottom of these shrinking, salty pools. The silence of the dying sea would have been absolute. And then, as the last of the water evaporated from these great basins, a new and alien landscape began to emerge. The salt, now unable to stay dissolved in the super-concentrated brine, began to crystallize. Imagine standing on a ridge overlooking one of these basins. You would witness one of the most surreal spectacles in all of geological history, not a sea of blue, but a sea of white. Vast, glittering fields of salt crystals would begin to form, spreading across the basin floor. This was not a thin dusting of salt. This was a geological deposit of immense scale. In some areas, the salt layer would grow to be over a kilometer thick, a solid, crystalline stratum, burying the old seafloor. The sun would beat down on these brilliant white plains, creating a landscape of blinding, shimmering heat. There would be mountains of salt, valleys of salt, and plains of salt stretching to the horizon. It was a sterile, beautiful, and utterly alien world, born from the ghost of a dead ocean. The Great Sea did not vanish in a single, final act of evaporation. Its death was a drawn-out affair, a slow fragmentation that transformed a single body of water into a string of otherworldly, dying lakes. As the sea level continued its relentless descent, the complex topography of the Mediterranean floor began to emerge from the water. Great submarine ridges, the underwater equivalent of mountain ranges, broke the surface, acting as new natural dams. The once unified sea was now partitioned, its deeper basins isolated from one another, creating a series of vast, disconnected lakes. Each of these lakes became its own separate experiment in desiccation. The rivers of Europe and Africa continued to pour fresh water into some, while others were left almost entirely to the mercy of the sun. In these isolated basins, the process of evaporation continued, but now its effects were concentrated. As pure water was lifted into the sky, the salt remained, and the salinity of these lakes began to climb to levels that life, as we know it, could not endure. The water would have become thick, almost oily, with dissolved salts and minerals. The vibrant blue of the old ocean would have given way to strange chemical hues. Any fish or marine life that had been trapped in these basins during the separation would have faced a slow, suffocating end as the water became too salty to support them. Their remains would sink to the bottom, forming thick layers of organic matter that would eventually be preserved under a blanket of salt, a silent graveyard at the bottom of a dying lake. These were the first hypersaline lakes, natural bodies of water with salt concentrations far exceeding that of the ocean, much like the Dead Sea or the Great Salt Lake today, but on a scale that was continental. The air around them would have been heavy and smelled sharply of salt and minerals. The shorelines would not be sand, but crusty, white salt flats, expanding daily as the water continued to shrink. This was a transitional world, no longer an ocean, but not yet a desert. A strange and sterile landscape of chemical ponds, a quiet and final testament to a world in the midst of a profound and irreversible change. As the Hypersaline lakes continued to shrink under the relentless sun, they reached a point of no return. The water became so saturated with salt that it could no longer hold it in solution. This was the beginning of the Great Crystallization, a slow and silent process that would transform the floor of the Mediterranean into a landscape from another world. Imagine standing on a newly exposed ridge, looking down into one of the deep basins. As the last of the water evaporated, the salt began to precipitate out, forming a crust. But this was not like the fine salt you might find on a shoreline today. This was a geological event. In the immense, still, super-concentrated brine, crystals of halite, the mineral form of sodium chloride, began to grow. With no currents to disturb them, and thousands of years to develop, they reached sizes rarely seen on Earth. They were not small grains, but massive, transparent, cubic crystals, some perhaps as large as a house. Layer upon layer, these giant crystals would form, locking together, to create a solid, crystalline pavement, a floor of pure, clear salt that could be hundreds, or even thousands, of meters thick. This was a world of profound silence and surreal beauty. The sun would have struck these vast fields of crystal, refracting and reflecting in a dazzling, blinding display of light. The landscape would have been a shimmering, geometric expanse of white and crystal, stretching as far as the eye could see. There were no plants, no animals, no sound but the whisper of the hot, dry wind across the salt flats. This was the Messinian Salt Desert, a testament to the immense power of evaporation, a quiet, crystalline monument to a lost ocean, waiting patiently in the deep, dark basin for the water to one day return. After thousands of years of relentless evaporation, the last of the great hypersaline lakes finally gave up its water to the sky. The process was complete. The Mediterranean Sea was gone. In its place was a landscape so extreme and so alien that it has few parallels in Earth's history. This was the Messinian salinity crisis at its peak, a world defined by a vast, hot, and profoundly deep desert. Imagine standing at the edge of this new world, perhaps on a cliff in what is now southern Italy. The familiar blue sea is gone. Instead, before you stretches a colossal, sunken plain, a basin of white and gray, shimmering under a harsh sun. This is no ordinary desert. Its floor lies kilometers below the level of the world's oceans. Due to the immense weight of water that was removed, and some continued geological subsidence, the deepest parts of the Mediterranean basin, in the Ionian Sea, now lay more than 3, perhaps even close to 5, kilometers below global sea level. This was a world of staggering vertical scale. The great islands of the Mediterranean, like Sicily and Crete, were no longer islands but colossal, flat-topped mountains, rising thousands of meters from the barren desert floor. The rivers of Europe and Africa that once flowed gently into the sea now plunged over immense cliffs at the edge of the basin, creating waterfalls that would have dwarfed any that exist today. They cascaded down into the hot, dry abyss. But their water did not form new lakes. The rate of evaporation was so intense that these great rivers likely vanished into steam and salt flats before they could travel far across the desert floor. The climate within this deep basin would have been brutal. With no moderating ocean, temperatures would have soared to extreme levels, far hotter than any natural desert on Earth today. The air would be thick with salt dust, and the pressure at the bottom of the basin would have been significantly higher than at sea level. The landscape itself was one of desolate grandeur, vast plains of cracked salt, towering mountains of exposed rock that were once islands, and deep, shadowed canyons carved by the dying rivers. It was a sterile and silent world, a geological scar on the face of the planet, a testament to what happens when an ocean is severed from its lifeline and left to the mercy of the sun. For a time, it must have seemed that this was a permanent state, that a great sea had been lost forever, replaced by an impassable, inhospitable wasteland. But the great game of tectonic plates was not over, and the Atlantic Ocean was patiently waiting just beyond the thin barrier of land at Gibraltar, waiting for a chance to reclaim its lost territory. The vast, sunken desert that was once the Mediterranean Sea would have been a world with its own, unique and brutal climate, a climate unlike almost anything on Earth today. Being kilometers below global sea level, the atmospheric pressure at the bottom of the basin would have been significantly higher than what we are used to, creating a thick, heavy air. This high pressure, combined with the lack of a moderating ocean and the intense, direct sunlight, would have created a superheated environment. The sun's energy, once trapped, would have had nowhere to go, with temperatures on the desert floor likely soaring to unbearable levels, perhaps 50, 60, or even 70 degrees Celsius. The air itself would have been incredibly dry and filled with fine salt dust, whipped up by the hot winds that would have scoured the salt plains. Breathing this air would have been difficult, a harsh, saline wind that offered no relief. From the north and south, the great rivers that had once fed the Nile, the Rhone, the Ebro would have continued their journey to the edge of this great abyss. Here, they would have plunged over colossal cliffs, creating waterfalls thousands of meters high, far greater and more powerful than any that exist today. But as this water cascaded down into the superheated basin below, it would have been met with an intense wall of heat. Much of the water would have likely evaporated into great plumes of steam before even reaching the desert floor. The water that did reach the bottom would have been a hypersaline brine, quickly spreading out and evaporating, leaving behind yet more layers of salt. Over thousands of years, these dying rivers carved immense, steep-walled canyons into the landscape, some of which were far deeper than the Grand Canyon we know today. Their empty, winding paths a testament to the water that once was. This would have been a world of profound stillness. The only sounds would be the whisper of the hot wind across the salt flats and the distant, hissing roar of the great waterfalls evaporating into the abyss. It was a stable, but dead, equilibrium. A deep wound on the surface of the planet. A landscape of geological extremes. A world lost to time, seemingly destined to remain a sterile salt desert forever. The Great Salt Desert, kilometers deep and shimmering with a blinding, sterile heat, would have been one of the most inhospitable places on the face of the planet. It was a world seemingly devoid of life, a vast monument to a dead ocean. By all conventional logic, no complex organism could have survived this transition. The lush marine ecosystems were gone. The rivers that once fed the sea now vanished into steam and salt. The land itself was a baked, barren wasteland. And yet, life is stubbornly, miraculously persistent. Even in this seemingly dead world, a different, more ancient form of life may have clung on in the most sheltered and extreme pockets of the abyss. This was not a world for fish or forests, but for extremophiles. These are organisms, mostly microbes, that thrive in conditions that would be instantly lethal to almost everything else. And the Messinian desert would have been their kingdom. The key to survival here would have been a tolerance for incredible salinity. In the final stages of evaporation, before the last of the water disappeared, the remaining brine pools would have become so concentrated with salt that they were thick and syrupy. Yet, even in such environments, certain types of bacteria and archaea, known as halophiles, or salt lovers, can survive. Imagine these last, dying pools, not teeming with fish, but tinted strange color spinks, oranges, and deep reds be the pigments of these microbial survivors. Here, in this chemical soup, these tiny, ancient life forms would have eked out an existence, drawing energy not from a complex food web, but from simple chemical reactions with the surrounding minerals and the faint, filtered sunlight. They would be the last, quiet inhabitants of a lost world. Even after the final pools evaporated, life might have endured. Some microbes have the ability to go dormant, encasing themselves in protective cysts, waiting for centuries or even millennia for a single drop of water to reawaken them. Others may have found refuge in the porous, salt-encrusted rocks, living within tiny, water-filled crevices, protected from the harshest surface conditions. This was not life as we know it, full of motion and sound. This was life reduced to its most patient and fundamental essence. A silent, microbial kingdom, a whisper of biological activity in a vast, sleeping desert, waiting in the deep and quiet heart of the world for the great flood that it could not have possibly anticipated. For thousands of years, the world existed in this strange and dramatic equilibrium, a deep, salt-encrusted desert lying next to a vast, full ocean, separated only by a thin and fragile bridge of land. This natural dam, the Isthmus of Gibraltar, was the only thing holding back the immense weight of the Atlantic Ocean from the empty abyss of the Mediterranean basin. On one side of this rocky barrier, the Atlantic churned with all its power. On the other side, kilometers below, lay a silent, superheated desert. The pressure differential was enormous. The game of tectonics that had closed the gates was still at play. But another force was now at work. The relentless power of erosion. The Atlantic was constantly pushing against the dam, its waves and currents wearing away at the rock, millimeter by millimeter, year by year. And from the other side, the rivers that once flowed into the Mediterranean now flowed toward this land bridge, carving channels from the east. The dam was being assaulted from both sides. No one knows the exact trigger that marked the beginning of the end. Perhaps it was a tectonic shift, a major earthquake that created a new fault line, cracking the integrity of the land bridge. Perhaps it was simply the patient, ceaseless erosion of water finally finding a single, critical weak point. Or perhaps the global sea level of the Atlantic rose just enough to finally spill over the lowest point of the ridge. But at some point, around 5.33 million years ago, the dam was breached. A small trickle of water, the first Atlantic water to enter the basin in hundreds of thousands of years, began to seep through a crack. At first, it would have been a small stream, a salty rivulet, carving a fresh path through the rock and earth. But the power of flowing water, especially water with such a colossal drop in elevation ahead of it, is immense. This small stream quickly became a raging river. The soft marl and sedimentary rock of the dam would have been torn away with incredible speed. The channel grew wider and deeper, hour by hour. The trickle had become a torrent. The torrent was becoming a cataclysm. The great dam was failing. And the Atlantic Ocean, after an eternity of waiting, was about to reclaim its lost sea in what would become the greatest waterfall and the most dramatic flood in the known history of our planet. The moment the rock and earth of the Gibraltar land bridge finally gave way, the world witnessed a flood of truly biblical proportions. This was the Zanclean Flood, an event so powerful it dwarfs any other flood in known geological history. It began not as a gentle overflow, but as a catastrophic failure of the natural dam. The initial channel, carved by the first trickles of water, was torn open with unimaginable violence by the immense pressure of the Atlantic Ocean behind it. What had been a river became a torrent, and the torrent became a waterfall of continental scale. Imagine a waterfall thousands of times more powerful than Niagara Falls, a cataract with a flow rate 1,000 times greater than the Amazon River today, plunging down into an abyss several kilometers deep. The roar would have been deafening, a constant, world-shaking thunder that could be heard hundreds, perhaps thousands, of kilometers away. The spray from this immense waterfall would have created its own violent weather systems, with perpetual storms and torrential rains at the base of the cascade. This was not a gentle refilling. This was a violent rebirth. The immense power of the water carved a deep and permanent canyon through the Gibraltar Sill, the very channel we know today as the Strait of Gibraltar. It tore away billions of tons of rock, reshaping the landscape in a matter of months or years. The Atlantic did not seep back into the Mediterranean. It blasted its way back in, a roaring, unstoppable force of nature, reclaiming its lost sea with a power that is difficult for the human mind to comprehend. The Great Zanclean Flood was not a slow, gentle rise of the sea. It was a process of breathtaking speed and power. As the immense waterfall at Gibraltar roared into the abyss, the water level within the vast Mediterranean basin began to rise at a rate that is difficult for the human mind to grasp. Scientific models, based on the scale of the Gibraltar Channel and the volume of the basin, estimate that the sea level may have risen by more than 10 meters per day. Imagine a tide that does not ebb, but only flows, a relentless rise that would be visibly noticeable hour by hour. Each day, the advancing water would claim new territory. The vast salt flats at the bottom of the abyss would have been the first to be submerged, their brilliant white crystals dissolving back into the turbulent, incoming seawater. The strange, hypersaline world that had existed for hundreds of thousands of years was being erased in a matter of weeks. The great mountains that were once islands, their peaks thousands of meters above the desert floor, would have witnessed the sea climbing their slopes with astonishing speed. Shorelines would not have been stable. They would have been a constantly moving, advancing front of water. This rapid refilling was not a peaceful process. The immense weight of the newly added water would have put enormous stress on the Earth's crust below, likely triggering constant, powerful earthquakes as the basin floor settled and adjusted. The water itself would have been a chaotic, churning maelstrom, filled with sediment and dissolved salt, a violent soup of reclamation. For the first time in an age, the rivers of Europe and Africa did not cascade into a dry abyss, but into a rapidly rising sea. Their steep canyons, carved during the dry period, were flooded, becoming the deep underwater canyons that we can still map today. And finally, after a period that may have lasted from just a few months to perhaps 2 years, the process was complete. The water level in the Mediterranean reached equilibrium with the Atlantic Ocean. The great waterfall at Gibraltar fell silent, replaced by the deep, steady current we know today. The Mediterranean Sea was reborn. A dead desert had been transformed back into a living ocean, a new world ready for life to return and begin its next great chapter. The dramatic story of the Mediterranean's death and rebirth seems so fantastic that it might be mistaken for a myth, but this is not a myth. It is a scientific theory built upon a mountain of hard, physical evidence, a story uncovered by decades of geological detective work. Our journey now shifts from the distant past to the modern era, to see how scientists piece together the clues to this extraordinary event. For a long time, the theory was just a fringe idea, a wild hypothesis. But in 1970, a deep-sea drilling expedition in the Mediterranean Sea changed everything. A research vessel named the Glomar Challenger drilled deep into the seabed at various locations across the basin. Scientists expected to find a continuous record of deep ocean sediments stretching back millions of years. Instead, they found something completely unexpected and baffling. Beneath the normal marine mud, they discovered a thick, extensive layer of salt and gypsum, the kind of evaporite minerals that only form when a massive body of salt water dries up. This layer, known in some places as the Messinian salt layer, was in some places over a kilometer thick. This was the smoking gun. The presence of this immense, buried salt deposit was undeniable proof that the Mediterranean Sea had, at some point in its past, almost completely evaporated. Subsequent seismic surveys, which used sound waves to map the layers beneath the seafloor, confirmed the discovery. They revealed that this salt layer stretched across nearly the entire Mediterranean basin, a ghostly remnant of the Great Salt Desert. These surveys also revealed the immense, deeply cut canyons that had been carved by rivers flowing into the dry basin, which are now buried under kilometers of younger sediment. Scientists could even trace the path of the ancient Nile River, showing how it had cut a canyon thousands of meters deep as it plunged into the abyss. The evidence was clear. The Mediterranean had indeed been a desert. And by dating the layers of rock above and below the salt deposit, geologists were able to pinpoint the timing of this event, the Messinian salinity crisis, to a period between 5.96 and 5.33 million years ago, a story written in the very strata of the Earth. The discovery of the Great Salt Layer and the buried canyons confirmed the what, where, and when of this incredible geological event. But it also opened up a new and fascinating question. What was the impact of this crisis on the evolution of life itself? The Messinian salinity crisis was not just a geological spectacle, it was a profound evolutionary event that reshuffled the deck of life across two continents, leaving behind an invisible legacy that can still be traced today. As the sea level dropped, it would have briefly, on a geological timescale, created new pathways for animals to migrate. Land bridges would have emerged, connecting what are now islands like Sicily, Sardinia, and Crete to the mainlands of Europe and Africa. This would have allowed for a great exchange of fauna. The fossil record from this period shows evidence of this migration. Animals that were once native to Africa, such as early relatives of elephants and hippos, were able to walk into Europe. And European animals, in turn, could have moved south. For a time, the floor of the Mediterranean was not a barrier, but a bridge. But just as it created bridges, the subsequent Zanclean Flood created insurmountable barriers. When the Atlantic waters catastrophically refilled the basin in a matter of years, these new animal populations would have become instantly and completely isolated. Animals that had migrated to the newly accessible mountaintops, which were formerly islands, were now trapped on them once again. This sudden isolation is a powerful engine for evolution. On islands like Crete and Cyprus, trapped populations of elephants and hippos, faced with limited resources, evolved into dwarf species, some no larger than a modern-day pig. This phenomenon, known as insular dwarfism, is a direct, living echo of the Great Flood. In the sea itself, the impact was even more absolute. The extreme salinity of the Messinian period would have wiped out nearly all of the native Mediterranean marine life. It was a near-total sterilization event. When the Atlantic waters returned, they brought with them the species of the open ocean. The modern Mediterranean ecosystem is therefore geologically very young and has a distinctly Atlantic character. It is an ocean largely without a deep, native memory. Its original inhabitants almost entirely replaced by the descendants of the newcomers who arrived with the flood. The crisis acted as a great reset button, erasing an ancient ecosystem and starting a new one from scratch. The legacy of this event is a reminder that the history of life is written not just in the code of DNA, but in the very rocks and seas of a changing planet. And so, we arrive at the end of our journey into the deep past, having witnessed the death and spectacular rebirth of an entire ocean. The story of the Messinian salinity crisis is a profound reminder of the immense and restless power of our planet. It teaches us that the world we know, with its familiar maps and stable coastlines, is not a permanent fixture. It is a temporary arrangement. A single, beautiful scene in a much longer and more dramatic geological play. The forces that closed the gates of Gibraltar and emptied a sea are still at work today. The great tectonic plates continue their slow, inexorable dance, and the climate continues its own complex cycles of change. But this knowledge should not bring us fear. It should bring us a sense of wonder and perspective. It reminds us that destruction and creation are two sides of the same cosmic coin. The drying of a great sea created a world of surreal, crystalline beauty. The cataclysmic flood that erased that world brought new life and a new beginning. The Earth is a planet of constant, magnificent transformation. And perhaps the greatest peace can be found in accepting our small place within these grand, ancient rhythms. The world is not a static museum. It is a living, breathing, and ever-changing work of art. And as you now let your own mind drift into the quiet, restorative sea of sleep, you are participating in your own small, perfect cycle of renewal, a quiet echo of the great cycles of the planet itself. Sleep well.